What's on the other side of the Big Bang? Canadian scientists suspect that there could be another universe that started with the Big Bang, but flows in the opposite direction to ours. We know how much our universe loves symmetry. When you look in a mirror, you see a perfectly symmetrical version of yourself. Look at nature, for instance, and you'll find perfect symmetry everywhere. Butterfly wings, the patterns of a snowflake, even the crystals in a pinch of salt. Each one of them exhibits stunning symmetry. This exquisite order suggests the existence of a symmetry algorithm in the fabric of the universe. Perhaps, if we could unlock this algorithm, we could uncover the secrets of what lies beyond the Big Bang. Who knows? Maybe our universe is just one side of a two-sided mirror. Inspired by nature, Canadian scientists wondered if they could bring this symmetry, so prevalent in life, to the moment of the Big Bang. They questioned whether the symmetry algorithm in the universe could be extended beyond the Big Bang, to the other side. Within a naturally expanding universe model, could our universe have a symmetrical twin? They posed this question and sought to delve deeper into the secrets of the universe. Perhaps our universe, with its passionate adherence to symmetry, conceals the reflection of another universe on the other side of the Big Bang. However, their only motivation for this line of inquiry was not just the symmetry of a mirror. In fact, they had much more than the symmetry of a mirror to justify their investigation. The theory of CPT symmetry. This theory posits that our universe is governed by charge, parity, and time symmetry. That is, it suggests that the laws of physics remain unchanged when all three of these properties are simultaneously reversed. This idea serves as a powerful motivator for scientists aiming to uncover the secrets beyond the Big Bang. To put it simply, if you reverse the charges, positions, and time of particles all at once, the laws of physics would still hold true. At first glance, this might seem confusing, but it's how our nature operates. To explain it more concretely, in your mirror reflection, your right hand appears on the left side. Time flows backward instead of forward, and electrons carry a positive charge instead of a negative one. If such a universe exists, the laws of physics in that universe would have to be identical to those in our own. In other words, general relativity would function the same way in this reverse universe as it does in ours. Moreover, in quantum field theory and special relativity, the preservation of CPT symmetry is mandatory. The validity of these two foundational theories in physics hinges on the validity of CPT symmetry. So, what does this mean? You might be wondering. Well, this question brings us one step closer to understanding the symmetry algorithm of the universe. The work of scientists proposes that the universe is symmetric between the pre- and post-Big Bang eras, meaning that the Big Bang gave rise to a universe-anti-universe pair in both directions. According to them, this pair arises as a result of CPT symmetry, which many physical theories insist must exist. Researchers have presented a theoretical framework, grounded in the principles of general relativity, quantum field theory, and particle physics, to explain the origin and evolution of the universe, and they have demonstrated the mathematical foundation of this framework. It is important to note that a theory having a consistent mathematical model does not prove it to be true. However, a consistent mathematical model is a prerequisite for initiating the experimental testing process. For this reason, the fact that this study relies on a coherent mathematical model is essential for the scientific validity of its content. The CPT symmetric universe model presented in the paper argues that the Big Bang was not a conventional explosion, but rather a symmetry axis that created a universe expanding symmetrically in both directions of time. This model posits that the Big Bang is not just an initial point, but also a point of symmetry. The CPT symmetric universe model suggests that our universe is a matter-dominated universe, while the universe in the other direction of the Big Bang is an antimatter-dominated universe. In our universe, time flows forward and entropy increases. In the anti-universe, time flows backward relative to our perspective, but entropy still increases within its own framework. This demonstrates that the thermodynamic arrows operate symmetrically in both universes. The study implies that matter particles dominate in our universe, while antimatter particles prevail in the symmetric universe. Each universe is a perfect mirror image of the other. This means that as you watch this video, your anti-self in the anti-universe is also watching this video. Time flows backward from our perspective when observing the anti-universe, But for an observer in the anti-universe, time flows forward. Upon hearing such a theory, the first question that comes to mind is inevitably why these two universes do not mix. This is also addressed in the paper. It appears that the Big Bang created a cosmological barrier between the two universes. Additionally, the fact that the entropy flow directions in the two universes are exact opposites prevents any interaction between them. The authors explain this by noting that CPT symmetry inherently prevents such an overlap. Do you and your reflection in the mirror mix together? Testing this theory might seem to require accessing the other universe, which would presumably result in everything ceasing to exist, leading one to think that the theory is unfalsifiable or unprovable. However, the scientists argue that this is not the case. According to the paper, if the anti-universe truly exists, then no long-wavelength gravitational waves should have formed during the Big Bang. If we find no traces of long-wavelength gravitational waves in the CMB, it could be a sign that an anti-universe exists. Once again, we arrive at gravitational wave detectors. In 1928, when the existence of antimatter was theoretically proposed, many laughed at the idea. But today, even small amounts of antimatter are being produced almost daily at CERN. For this reason, the future of anti-universe cosmology models seems bright. Stay tuned for our next video.